Hello, welcome back. Another lecture and some more important information. I want to tell you all the important features of the Kotlin programming language. This will help you understand why Kotlin is so awesome and why I recommend it. Static typing. Before we talk about static typing, I just want to give you a little overview of what a data type is. We're going to have a detailed lecture on data types and variables, but in order to understand static typing, you have to understand what data types are. And so a data type is just associating a variable with a type of data. So some examples of data types would be things like strings, ints, floats, numbers versus text. And in languages, you either have to identify the data, the type of the data, or you don't have to identify the type of the data. And that's referred to as strong or weak typing. Strong or weak typing is not concerned with static typing. Static typing is a little bit different. But I wanted to give you that overview. It's just data that's associated with variables, the type of the data, numbers versus text. So there are many interesting features in Kotlin that are shared with Java or that do not exist in Java. I'm going to try to identify those differences, the similarities, and as well as the similarities, and identify some of these great features that Kotlin has that Java doesn't. Kotlin and Java both are statically typed. But there is an advantage with Kotlin because we have this thing called type inference, which I'll talk about in a second. But a statically typed language has nothing to do with strong or weak types. All it has to do is when is the data checked? Is it checked at runtime or is it checked at compile time? With a statically typed language, the variables, the data that they have, are always checked at compile time. The JVM does support both dynamically and statically typed languages. Some of the dynamically typed languages are Groovy and JRuby. But Kotlin is a statically typed language. It checks its data at compile time. The advantages of checking your data at compile time, performance is better. When you have runtime, when you do runtime calculations in any language, it's going to hit the performance a bit. If you have dynamic lookups, polymorphism, it's always going to hit performance. If you don't have to look up the types of the data at runtime, performance is going to be increased. You don't have to figure out this extra thing. The JVM has enough to worry about. They don't have to worry about dynamically looking up data types. Programs are also a lot more reliable because there are fewer crashes at runtime. Instead of runtime finding the error, the compiler finds the error. And so if you find the error earlier, the program is less likely to crash. What happens with dynamically typed languages are that since the compiler is not checking the type of that data, you may assign number data to a string data. And at runtime, the JVM doesn't know how to handle that, so it just crashes. So compile time checking is a big deal. Code is also easier to maintain because you can identify the types better. When you look at the code and you're identifying, now this has to do more with strongly versus weakly typed languages, but if you look at the code and you see data types that are associated with variables, it's easier to follow the code. Dynamic typed languages tend to be more loosely typed versus static typing that are more strong typed, but that's not the case. They're two unrelated concepts. Also, the big feature of Kotlin in relation to static typing is this concept of type inference. Like I mentioned, in Java, with static typing, you identify the type of the data when you declare it. You say int x, float y, and so forth. It's tedious. You have to identify the data. In Kotlin, you don't always have to do this. The compiler will figure it out for you. If you're assigning a string or text data to a variable that doesn't have a type, the compiler will say, "Oh, you must be assigning string, so I'm going to make that type of string." It automatically does this calculation for you. So types can be determined from the context. That's type inference, and it's supported by Kotlin, and it's cool. It's really cool because you don't have to specify data types all the time. It can increase productivity. Kotlin also supports the object-oriented programming paradigm and the functional paradigm. So this is pretty cool because you can do functional concepts along with object-oriented concepts. We'll have lectures that define these methodologies in detail. But Kotlin is both an object-oriented language and a functional language. It's designed around objects. It supports concepts such as inheritance, polymorphism, and generics. Again, those terms might be completely clueless to you, but we're going to explain them. You just need to know that you can program in different methodologies in Kotlin. You're not restricted to just objects or functions. It's not a purely functional language, but it supports many concepts of functional programming. Functional program has things like lambda expressions, first-class functions, immutability, this concept of no side effects. So you don't have to necessarily declare anonymous interclasses every time you need to implement an event handler like you do in Java, especially with Android apps. For those of you that created Android apps, we all know these anonymous interclasses for event handlers. You don't have to do that in Kotlin because it's functional. You can pass blocks of code that represent functions. And so it reduces the amount of anonymous interclasses that you need. And functional programming also has a lot of other benefits. You don't have to use functional or object-oriented. You can do one or the other. You can mix them. It's a really good feature of Kotlin. Another big language feature is this concept of lambdas, which I just briefly mentioned. They're also referred to as higher-order functions. Lambdas lets you pass around blocks of code, providing a concise syntax for creating immutable objects. So as I mentioned earlier, Android only supports Java 6. I think with the latest Android O, it's starting to support some Java 8 features. Java 8 has lambdas in them, but Android apps don't support lambdas. So with Kotlin, you can pass around code as blocks into functions. It's a really neat concept, and it has a lot of advantages. Referred to as an anonymous function, that's what a lambda is. It can replace anonymous classes. It's only used once. It's often passed as an argument to a function. We're going to go through lambdas in great detail. You can utilize lambdas in the following situations. If you need a function to return another function, if you have a large number of very similar functions, all of which will be used for the same purpose, you can pass in a block of code. When you're generating an arbitrary number of functions based on input from the user, from a configuration file, database, or similar source, you can use a lambda and just pass that around. Again, very, very useful. Another great feature of Kotlin is this concept of null safety. We briefly talked about this in a previous lecture. But before we talk about this, we know interoperability is a big deal. That's a big language feature where you can continue to use most libraries and code written in Java. You can mix projects with Java and Kotlin code. They can coexist. There's also null safety. When you write Java code, you often have to write defensive code. This is where you have to check whether an object is null before using it. You have runtime exceptions with null pointers. It's a real pain in the butt. With Kotlin, you don't have to worry about this. You can use save call operators and many other ways to prevent null pointer exceptions. Kotlin only allows null pointer exceptions if you have an explicit call to cause a null pointer exception. You throw it with the throw keyword in Java, or if external Java code has caused it. So Kotlin is a null safety language. Less crashes. We also have this idea of extension functions and operator overloading. Extension functions, you can extend any class with new features even if you do not have access to the source code. So the Java APIs, you can extend the collection classes. You can add any new functions to any class. There's an any type in Kotlin that's supported that's similar to the Java object. It's the superclass of all types. And you can extend any class in Kotlin. So it's a better substitute than adding the usual utility classes. In the past, in Java, you would have to add a utility class if you wanted to add new features to API classes. You don't need to do that in Kotlin. We also have operator overloading in Kotlin. This is where you can redefine behavior for operators. Operators are things like arithmetic operators or logical operators, plus equals or equals equals or and. You can override all these operators to have your own behavior. So the overload operators are treated as polymorphic functions, different behavior with the same type. And as a result, they have different behaviors depending on the types of its arguments. So nice feature that Java does not have, operator overloading. And as I mentioned, Kotlin does the extension functions quite a bit with the Java collections package. Generics. Java has generics. Kotlin does too. This is kind of the opposite of polymorphism. Generics enable types, classes, interfaces to be parameters when defining classes, interface, and methods. So you have this concept of type parameters. They provide a way for you to reuse the same code with different inputs. The inputs to the type parameters are types. Typically when you pass information to a method, you pass data. You don't pass types. Generics allow you to pass in types. Based on the types, you have the same behavior. You can greatly reduce your code by using generics. Like I mentioned, it's the opposite of polymorphism. Polymorphism is this concept of you have the same type of data, but you have different behavior. With generics, you have different types, but you have the same behavior. It's similar to C++ templates, if you've ever used those. There's also many other features in language that we don't have time to discuss in a single lecture, but we'll talk throughout the class. Things like properties, similar to member variables, but more advantageous. Reflection. Reflection is an advanced concept. We'll briefly talk about it. It's a way to do compile time stuff and have not have to compile things and so forth. Smart casts, this idea of the compiler automatically inferring data type conversions. Companion objects, range expressions. We're going to talk all about this, but a lot of nice features in Kotlin. Data classes, another nice feature. These simplify classes. I showed you that example in our previous lecture where you could have a data class. You don't have to add getters and setters, and you automatically have methods equals hash code copy and toString. In Java, you would automatically have to override these methods in your class. So data classes can clarify the intention of the model and what should go in it, separating pure data from the business logic. And I showed you an example of this previously. Comparison to Java. Some Java features that Kotlin lacks. Java has checked exceptions. Kotlin does not. Exceptions are a concept where if you have a runtime error in your code, as opposed to the program crashing, you can gracefully exit by handling that exception. Checked exceptions are compile time checks that Kotlin does not have. Java also has primitive data types like ints and floats. They're not objects, and as a result, you have to convert them to objects when you pass them to methods using the autobox classes in Java, integers and strings, integers and floats, I should say. Static members. There's no concept of a static member in Kotlin. Static members are class data, global data shared amongst all classes. Non-private fields. Java has public fields. You can share the data publicly outside of the client. The client can automatically access it. You can't do this in Kotlin. Public data can cause problems with encapsulation. There's also wildcard types in Java that does not exist in Kotlin. Mainly has to do with generics. Kotlin features that are not in Java. We mentioned the lambda expressions, passing blocks of code to functions, inline functions, extension functions, the ability to extend existing classes without the source code, null safety, reducing null pointer exceptions, smart casts, the compiler automatically infers type conversions, string templates. String templates are a nice concept where you don't have to do concatenation as much with string templates. You can have concatenation automatically handled for you with triple quotes and things like that. Properties, singletons. Singletons are creating a single instance of a class. Very nicely done in Kotlin. Operator overloading. Companion objects, data classes, coroutines. All these things we're going to talk about. There's a lot of features that improve upon Java that are included in Kotlin that Java lacks. Mainly because Android is still stuck on Java 6 and Java 8 doesn't have some of these nice things. So we're going to talk about all these awesome features. You're going to recognize how great Kotlin is, how it makes your life much easier, and you're going to love Kotlin. So thanks.